Problem number 5, antiderivative of 3x squared is x cubed. 8x antiderivative is 4x squared. That's being evaluated from 1 to 3. So we plug in 3 first, and we have 3 cubed minus 4 times 3 squared minus, now we plug in the 1, 1 cubed minus 4 times 1 squared. 3 squared is 9, 3 cubed, that should be a cube there, my bad. 3 cubed is 27, 3 squared is 9 times 4 is 36. So we have 27 minus 36. Over here we have 1 minus 1 squared doesn't matter, so we just have 1 minus 4. Okay, so 27 minus 36 is negative 9, and then we are subtracting negative 3, which means we're really adding 3, so our final answer is negative 6. Alright, we have our first negative exponent. X to the negative 1 is antiderivative, x to the negative 2 is antiderivative is x to the negative 1 over negative 1, and that's being evaluated from 2 to 4. Plugging 2 and 4 in for a negative exponent may not be the easiest thing, so perhaps we should rewrite this. X to the negative 1 becomes x to the positive 1 if we just move it down into the denominator. The negative sign doesn't really matter where that goes. It can be in the denominator, it can be in the numerator, or it can be out front. I'll move it up into the numerator. So we have negative 1 over x as our antiderivative. Again, x to the negative 1 over negative 1 can be rewritten as negative 1 over x. That's still evaluated from 2 to 4. We plug the 4 in first, so we have negative 1 over 4. Minus, now we plug in the 2, so we have negative 1 over 2. Double negative means we're adding, so we have negative a quarter plus a half. A half is 2 quarters, so negative a quarter plus 2 quarters is 1 quarter. Number 7 is going to require us to do a little work before we take our antiderivative. We don't have a rule set up for this. We do have this x squared in the numerator, and we have x plus 2 in the denominator, but there's no basic antiderivative rule, so we need to simplify this. How do we do so? Well, we have to identify that the numerator is the difference of 2 squares, which means what we're really looking at here is the integral from 1 to 3 of x plus 2 times x minus 2 in our numerator. X plus 2 is still in the denominator, dx is afterwards. Our x plus 2's can now eliminate each other, so what we're really being asked to do is the integral from 1 to 3 of x minus 2 dx. Alright, that's not that bad of an antiderivative. That's x squared over 2 minus 2x. And it's being evaluated from 1 to 3. So we plug the 3 in first. Doing so gives us 9 squared over 2 minus 2 times 3. And then we plug in the 1. So we have 1 squared over 2 minus 2 times 1. And again, we need parentheses around the whole thing. So we have 9 halves minus 6. 6 is 12 halves, right? 6 is 12 divided by 2. So, what did I do here? Oh, my bad. That should be just 9, not 9 squared. So we have 9 halves minus 12 halves. And then we are subtracting, and we have 1 half minus 2 is the same thing as 4 halves. That's lots of halves, so let's see if we can simplify this a little bit. 9 minus 12 is negative 3. Minus 1 minus 4 is also negative 3. Oh, we get a number subtracting itself, which means they wipe each other out. And our integral's answer is 0. Okay, another one in which we need to rewrite. We are dividing both parts of the numerator by x, so this is the equivalent of the integral from 1 to e of 1 over x minus x squared over x dx. And slide over a touch. There we go. And then we can simplify that second term, so we have the integral from 1 to e of 1 over x minus x dx. Okay, let's do some anti-deriving now. This we could not anti-derive, this we can. 1 over x is antiderivative, is the natural log of x, And x's antiderivative is x squared over 2, and that's evaluated from 1 to e. Okay, we're going to plug e in first. So we have the natural log of e minus e squared over 2. And we have the natural log of 1 minus 1 squared over 2. Okay, so some simplifying here. The natural log of e is 1. We cannot simplify e squared over 2. Natural log of 1 is 0. That second part is just 1/2. So we have 1 minus e squared over 2 minus negative 1/2. Which really means we're adding 1/2, so we have 1 plus 1/2, or 3/2 minus e squared over 2. And when you check this one on the calculator, you have to also punch in 3/2 minus e squared over 2, and you'll see that you get the same messy decimal.